On this video, we will talk about the sectional view and how some of these features are useful in creating the part modeling in Inventor. Some of these tools, such as mirrors and also constraining the symmetrical objects, we have used before. Here we looked more in depth in this section. We learned how to create revolve feature. We use the mirror feature command. We create new border and title block. And also we will learn how to create circular patterns. We will modify linear dimensions. And also we will create a symmetrical feature in design, and such as a pulley example that we will work on this chapter on also creating the sectional view on detailed drawing. So let's just review quickly on what is the sectional view and why we use sectional view. So we look into some of those. And so often our orthographic views, the one you're seeing here on the side view for this tool, this part rather, it's so complicated. You notice that so many hidden lines. So the goal or objective of creating the sectional view is to make it more clear to understand. So rather than looking from outside, which ordinarily we have been doing on orthographic projections, we have been projecting from the outside, and now all these invisible lines becomes hidden lines. So in sectional view, rather than looking from outside, we're going to look inside. So there will be imaginary cut through the object, and we look inside, and that would clarify some of the feature which otherwise we cannot see. So here what we see is the good illustration of the sectional view. So imagine we have a cutting tool. We cut this exactly in half, precisely in the center of this object. So now what we see here is the inside clearly, and all those invisible lines becomes visible. And so in other words, we will remove this front portion and look inside, and we see that. How we represent this on orthographic views or multi-view drawings is different now. So notice here we are seeing the same side view but much more clearly, and then we have all these hidden lines becomes visible, the solid lines, and then we have a pattern which represents the solid object. And any place that you see no lines or no section lines, they are where they're hollows, like holes. So any solid objects would be represented by these patterns. In traditional drawings, we used to use the simple one for all kind of materials. Now in the CAD, that's not the issue anymore, because doing this manually would be time-consuming process. So they have adapted this single lines for all kind of material, and the note would indicate what type of material is. Now for every single material, we have a different pattern, which in the CAD system, in the library, we have all those. So it's not the issue anymore. So we can bring the exact pattern matches with the material. So this is how basically the section would look like. Then we can look into some of the different types of sectioning. There are several types. And this is some of the also meaning of those lines. And you see the section lines have a line that has two arrows and pointing on the certain directions, which normally is the viewing directions. And the type of that line is the phantom line. We saw this type of line before earlier in chapter 7. And now we have also some drawings you may see this, which is dashed lines. Is also acceptable way of showing cutting plane lines. So that imaginary plane represented on the orthographic as line, what we call cutting plane lines. And now this arrow direction shows how we are viewing at Now, by cutting through this, we see this clearly here, how inside looks like. So there are Inventor, we have already this set up to be phantom line to be a default. So it's pretty much programmed to do that for us. We don't have to set the line types we used to in the other type of 2D CAD system. So here we have a general rule for sectional views. Important to keep in mind. They're always, you have to make that more understandable. That's the whole idea of doing the section. If you look at this illustration here, we have the top view, front view, and alternate right side view, which shows on here. And this is the section AA labeled, because we have more than one, and we have to define those with labeling AA and BB in this case. So BB represents this cutting plane line cuts through here, and then the same view also shows another one, which is AA, shows here. So if you cut through this portion, this is how it looks, and if you do this way, inside. Without these two, would not be clear. So that's basically some of the decision we have to make when we're creating the detailed drawings. And there are also, as I mentioned, the different patterns for different material. Again, like for instance, we have steel, shows like these two lines here, cast iron, and different general purposes usually use this one. As I mentioned in the manual drawing, always we use this because it was simpler to draw. Now in the CAD system, we have all this in the library. So then we have like bronze or any kind of composite material look like this one. As you see here, different pattern has a different meaning representing different material. And then we look into the type of sectioning. When we call full section, that means that we are cutting through all the way. So this is an example of full section. That's just the term to know what full section is. And again, we have another section, we call them half section. In half section, you're removing only quarter of the part. And the reason by doing this, we are showing outside and inside at the same time. And this was, again, some of those features in traditional drawing you will find more convenient to do because it was time consuming. If object is the symmetrical, there is no sense of showing both sides. Just show one of them, other one is the same. So it was a time saving process. Again, is not major concern in CAD system. So that's another thing we have to think about. Doing the half section is feasible or not in the CAD system. But again, you need to become familiar with the type of the section. If you see some word that says half section, it doesn't mean in cutting half. It means that cutting a portion of them is a quarter point, 1/4 of them is removed. In full section, we remove half of them. In half section, we remove quarter of them. And then we have another type of the section. This is still useful method to use called offset. Offset where you have often difficult to see inside when you have a lot of important feature to show. If I cut this piece, for instance, in the middle exactly, I'm going to lose some of this important feature like this slot, this adjustable hole here, if I cut here. So as you notice here, this cutting plane line zigzags through and then shows those important features, including this hole and this hole, that's the idea to show. Otherwise, we will not be able to show that. Remember, sectional view is the one that after you cut, you're looking on that direction of the arrow and you're drawing what you see. And so that's what we call offset, or bending the cutting plane. And again, when you bend, all of this is 90 degrees. We don't just jump in from this point to this point. We have to go 90 degrees every single line in reference to each other. This is an example of the offset section that shows here the result. As you notice here, that shows everything that was important to show. And this is pretty much illustration of that on the 3D model. And then we have another section type called broken out section. Broken out section is where, again, this was a time-saving feature in traditional drawing. Rather than showing the full section, we have cut the portion of them because it was important to show and dimension this part. Remember, one of the rules was not to dimension hidden lines. So in order to do that, we had to cut through and show inside clearly. And see, without that, would be all hidden lines here. So as you see, there is a short break line used to represent that. And then we have also what we call align section. This is still a useful method to use. Like this example we are going to do in this lab today, it's basically we are using the number of holes are even numbers, like 6, and one of them falls here. So it doesn't need to be aligned. But suppose it was 5 or 7, any odd numbers, 3, 9, all those, it produces a situation that if you do the true projection, this hole is going to be in location other than equally spaced from the center line. For that reason, we need to do align section. This gets a little bit confusing when you think about why we need to do that, and you need to experiment that in your inventor file by changing the number of the holes from 6 to 5, and you see the result. And that would not be clear until we run the cutting plane line through those features that we want to see. So that's what we call them align section. That's what it is, align section. And then you have also an example here that shows the half view, which is pretty much another half section. Pretty much we saw that one. It's just the differences here. Half view on the full section, and there's the half view on half section. We have a type of the section that is called revolved. Basically, you are showing that cut on the object. It is superimposed on the view itself. Notice here that is, without this, we would know what the shape looks like from just looking to this one. And now we see that this is a polygon shape and this is just a circular shape. So revolve, and that's another term called removed. Basically they are the same. In this case they have this one called removed because the same thing, they move them up here. As you see, this rectangle shape, and this is a circular polygon shape. This is too small, but it's the polygon shape. And so that's basically revolve and removed. What you do basically, rotate this 90 degrees, and either you show outside or show on the view itself. If it's on the view, we call them revolved. If it's moved somewhere else, normally on top of that, would call removed or revolved. Pretty much represent the same shape. Depending on the space on the paper, we decide how to do it. And then other sectional for conventional bricks we use, like in pipe or something like in the piece of wood. Let's say you have a 2x4 long piece. You don't want to show the entire thing. You just cut. There's two types of brick. We have a short brick and long brick. This is the one that's used, short brick, and this is the long brick. It's common for more construction, architectural drawings. And pretty much there are some exceptions. Remember, we mentioned that anything is solid, we do show cross section. There are some exceptions to that. And these are some of the mechanical terminology that we learned as ribs and webs, spoke, any kind of object that even though they are solid, but we do not run the section line through them, leave them blank. Like this case, they are leaving those blank. And so this is a good example to illustrate. If you look at the front view, and if this part is the solid piece, which technically should be sectioned. If you do that, you cannot show these lines. This should be disappeared. So it's not as clear if you do show, in other words, if you follow the rules, which is the section any solid object, this would not help here. So we have to make that decision here not to. So these are some exceptions we make. Okay. And basically any thin objects, any fastener devices like bolts, nuts, there are some other like washers, they are not sectioned, even though they are solid pieces. There are some exceptions to this. Now, the next video I'm going to talk about the Autodesk Inventor feature, how we use sectioning and create object with revolved feature.